Now, we saw the photoelectric effect demonstrated with the gold leaf electroscope, but you might think that beyond that, this whole quantum thing is so weird and so far beyond our everyday experience of the world that we wouldn't be able to investigate any more of it in the classroom. But in fact, amazingly, we can do a practical to find a value for the Planck constant using only this circuit here, which is something you've probably seen in a circuits lesson. Okay, so what we do is we use the potentiometer to vary the potential difference across the LED from 0 upwards. Now, if you're not sure about potentiometers, go back and watch the circuits videos. But we're going to start with the contact at this end so that the PD across the LED is 0. And then we're going to increase it, the PD, until the LED only just lights. Now, obviously, there's a huge amount of uncertainty in this practical, but this is what we do. So increase it until the LED only just lights, and then we write down what the PD reading is, and that is called Vmin, the minimum PD that will cause the LED to light. Now we also write down the wavelength of the LED, and that you just get from the manufacturer's information. Okay, once you've done that, you then change the LED to one with a different wavelength, so a different colour LED, and repeat. And you do that for, if you can, 5 LEDs. Now, what's happening with an LED is sort of the photoelectric effect in reverse, sort of. So in an LED, when a current is flowing, an electron is being accelerated through it, and then the kinetic energy of that electron is being converted into light. So the kinetic energy of an electron accelerated over this PD here, is EV. We've done that formula when we looked at accelerating electrons in the first video today. So that is the kinetic energy of an electron accelerated over this PD here. And we're saying that all of that energy gets turned into a photon of light. Well, the energy of that photon will be HF, or if we use the wave formula, hc over lambda. And so that means that if we plot Vmin on the y-axis against 1 over lambda on the x-axis, we are going to get a straight line through the origin. Now, why is that? If I try and squeeze it in here, I haven't left enough room. So if I just divide both sides by e there, I'm going to get hc over e lambda. And so Vmin is, if I just pull out my 1 over lambda there, so that is hc over e times my 1 over lambda. So the gradient of this line is hc over lambda. Sorry, hc over e. And these are all constants. And so we've got y equals mx. Y equals a constant times x. And no y-intercept, which is why it goes through the origin. And so then you can find the gradient, use the value you know for c, use the value you know for e, and get a value for h there. And you can have a go at all of that on this question. Okay, now I wasn't sure what they meant here. When explain the meaning, I wasn't exactly sure what they wanted. So remember, if you're not sure, more detail, loads of detail to make sure you get the marks. So I would have said that this is the kinetic energy of the electrons going through the LED, and it gets turned into the energy of the photon that comes out. And in fact, the mark scheme says the first mark is for saying that this is the energy of the electron, and that equals the energy of the emitted photon. So I think I'd have been okay there, both marks. Next part, we're describing the experiment. You can have any 3 of the following. 1. Adjust the potential divider to have 0 volts to start with. 2. Connect the flying lead to one of the LEDs. 3. Increase the voltage till it only just lights up. 4. Repeat it several times and take an average of the minimum voltage reading. 5. Repeat for each LED. 6. Shield the LED. Basically try to keep it in the dark so that it's easier to judge when the LED has just switched on. Any 3 of those. Next, you get 1 mark for getting both of those values right. Notice they must be to 3 significant figures. The second mark is for plotting both points correctly. Now, it doesn't say it here, but usually it's correct to the nearest half a small square. The third mark is for a straight line that goes through the origin. And the fourth mark is for the gradient. Remember to show your answer, unrounded answer, in order to prove that you have done it. Now this is what I would write to show that the gradient is equal to hc over E. What they've got is saying that the gradient is V lambda and then showing that using the equation. I can't see how this would be wrong, but if you do it the other way, then that's definitely going to get you the marks. And then lastly, using your value for the gradient to calculate a value for h. Okay, that was a busy day. More tomorrow.